मुझ में समाया वो जो तुझ में समाया मोरा वही वही माया वो जो मुझ में समाया वो जो तुझ में समाया मोरा वही वही माया कुन फाया कुन फाया कुन सदक़ल्लाहुल अलीयुल अज़ीम। रंग रेजा रंग मेरा तन मेरा मन ले ले रंगाई चाहे तन चाहे मन रंग रेजा रंग मेरा तन मेरा मन ले ले रंगाई चाहे तन चाहे मन सजरा सवेरा मेरे तन बरसे कजरा अंधेरा तेरी जलती ला सजरा सवेरा मेरे तन बरसे कजरा अंधेरा तेरी जलती ला कतरा मिला जो तेरे दर पर से ओ मौला मौला कुन फाया कुन फाया कुन फाया कुन फाया कुन फाया फाया
Alright, so I'm making a beat, and the artist insists that I use a ukulele for this. But I don't know how to play ukulele, and obviously I'm not telling him that. So here's me reluctantly walking to the ukulele. Now I'm just sitting like an idiot. I have no idea what to do, and he's still staring at me. The second he's distracted, I'm pulling up a chord chart just to try to figure this shit out. Now I'm recording for like a full 5 minutes, just wrong notes every single time. My hands are shaking. I'm making the stupidest faces. I finally get a single good take.
That's hard.
Oh, thank God.
Strawberry tattoos. You could take my top left, I can't choose. Meet me at the rendezvous.
Alright, so I'm making a beat, and the artist
welcome to a new section. In this simple shooter section, we are going to be making this the simple shooter game, and we're going to learn about movement animation. As you can see here, our character is a fully animated third-person character. We are going to be adding all sorts of intricacies to our movement system and our aiming system and animation on top of all of this. We're going to be adding a shooting mechanic, so you can see here shooting with particle effects, etc. Shooting, and we're going to have death and AI, so we're going to kill off our AI with our shooting mechanic, and also have health for ourselves. Finally, we're going to have a win-lose condition, so if I get shot to pieces, the game's going to notice that, and it's going to restart the level for us and display this handy message telling us what's going on. The same happens if we manage to kill off all the enemies in the level, we win and get a similar message, except it's green. So to recap, the project plan for the next series of 50 lectures or so is going to be, first of all, sorting out our player movement, then taking a bit of a deep dive into animation to make our third-person character look really cool. We're going to then have some sort of shooting architecture and gun architecture discussions to allow us to do that shooting. Then we're going to have health and death happen for both us and the AI. We're going to implement an enemy AI using behavior trees and teach you how to make your own behavior tree nodes in C++. And then we're going to implement a win-lose condition using the game mode and access to the level to detect whether all the enemies are dead and whether we are dead as well. So that's a rough outline of the section. Some things we're going to be looping back to multiple times, but this is the main stuff we're aiming to cover. So let's dive in and get our project set up. Hello and welcome. In this lecture, we are going to be adding in an asset pack with a whole bunch of beautiful assets, such as this great level here, which is going to be a fantastic starting point for our first-person shooter, as well as character assets, guns, particle effects, and more. So let's dive in and see how to do that. Now, before we get stuck into creating anything Unreal related, let's go and download the asset pack. It's in 3 separate zip files against this lecture, part 1, part 2, and part 3, each one about 1 gigabyte in size, so it might take a little while to download depending on your connection speed, so do get started on that. And once they have downloaded, you can go about extracting them in size. It's in, dive in and see how to do that. Now, before we get stuck into creating anything Unreal related, let's go and download the asset pack. It's in 3 separate zip files against this lecture, part 1, part 2, and part 3, each one about 1 gigabyte in size, so it might take a little while to download depending on your connection speed, so do get started on that. And once they have downloaded, you can go about extracting them. The way to do this off the part, there's no overlapping files, that extract it to any folder of your choosing, and it doesn't matter what order you're doing. Right click, extract all, and then just make sure you strip off the part 1 at the end of the folder name and hit extract, or extract it to any folder of your choosing. And it doesn't matter what order you extract these in, you can do part 1 as long. Then finally we're going to do the same thing for removing that part. Make sure you get all to be the same folder, appear to have all of the assets that I have. Go back and check you have asset pack inside the folder, which contains itself a shooter asset pack project. You can see it's popping up the windows as it's finishing. If you open that up, everything should be working correctly. If it's not working correctly, have a go at re-extracting them again. Now, you've done this a few times. 0.25 to get our new, to talk about the assets we're going to be using. Our project, and the way we're going to be doing this is it is itself a Unreal project, so we're going to migrate the assets out of that project and into your project. Basically, this, instead of having a starter project, this is just another way of doing it, and the benefit of this is that if you have got an existing project that you want to use these assets into that project. So let's create, first of all, a project to start with. Now you'll notice if this dialogue looks unfamiliar to you, it's because it's a little bit new in some newer versions of Unreal, but don't worry, it's not that different. Basically has the same options. We want to select games because that's what we're making. We're not doing any of these other applications that Unreal is often used for. So we'll select games and go to the next screen. Now it starts to look a bit familiar. So we want a blank project. Notice there's no tabs here for Blueprint or C++. Create a blank project. On this next screen, this is where we have the option to select between Blueprint or C++. I'm going to go for C++. It's a C++ course. Then all these other options I'm going to leave the same. I'm not going to add starter content, although you could if you wanted to have those extra assets in the starter pack to play around with in your shooter. Then I'm going to give my project a name, which is going to be simple shooter, the name of this section, and I'm already happy I've got that location set to the right thing. But you can go ahead and change the location to wherever you want your project to be saved, and go ahead and create the project. Again, this can take a variable amount of time. We're going to go back and have a look at the asset pack. So as I said, it is a U project, and in fact it made in version 4.22 if I'm correct, which means that you can use it in any version greater than 4.22. So we're going to go ahead and open it up. And that just explains why we see this first dialog box that says select an engine version, because the version of the project itself was not 4.25, so it's just going to do an upgrade. But that's fine, we can go ahead and do an upgrade to whatever version you've currently got on your system, and it should work just fine. And the zip for this asset pack can be found against this lecture's resources, so you do go ahead and download that. Get that extracting. It can take a little bit of time because there's quite a lot of heavy assets in there. Make sure you get that download started while you're watching this video. Now for the next step, we will need to have this discovering assets little dialogue have finished discovering all the assets in the project, because we can't migrate them if it doesn't know what they are. So what we're going to do basically is take this folder here, the asset packs folder. You can go and have a look at it. There's a few different asset packs that I've aggregated together from the permanently free collection, from Unreal's example projects, and some assets of my own which I have created with my microphone. And you can go and have a look at it and take a look at any of this. It's quite fun. Anyway, but we're going to try and migrate this. Let's right click on the asset pack and hit the migrate button. So we're doing this at the root folder, so that we're migrating all of these folders underneath it. You can see that it's selected them all automatically. And we're going to go ahead and click OK. That's all the assets that we want to migrate. Then what we need to do is go and navigate our way to the content folder of the project we want to import this into. You can see it's currently in the content folder of the project that we're importing them from. So the shooter asset pack content is where it currently is. But we want to go to where we've created the new project. So for me, that's under courses and Unreal, and then the simple shooter that we've just created. And then you can see that Unreal's created this content folder where all your blueprints and your assets generally live. So once you've got that, it's an empty content folder. We can just go ahead and hit select folder, and the copying process is going to start. Now this can take a little while because there's a few gigs of assets in here. There's quite a lot of high res assets for you to use. So once your download is finished, do go ahead and get started on this migration as soon as possible to bring those assets into your project. Okay, so once that is complete, you may get a message saying that some files were not successfully copied. That may or may not be a problem. We'll see down the line. We can always migrate things again if we find that something is missing. So let's take a brief look at what came in. We're going to go over to our simple shooter. We can now close down the shooter asset pack. We no longer need that project. You can delete it off your downloads if you like, or keep it around in case you want it for something else. Now, what's in the asset packs? I think the most interesting things to have a look at are the modular sci-fi season 1 starter bundle, which is in the permanently free collection, so you could go ahead and download this anywhere. I've just packaged it all together to make it simple. And what we're going to have a look at is the collection maps and map number 1. Go ahead and load that one up. So once that has opened, and it can take a while depending on your machine. For me, it took about 5 or 10 minutes to open this map, but don't worry, once you've opened it once, it's going to be a lot quicker in future. And what you're going to see is this kind of environment. At the first, it might be not particularly pretty, as you can see over here. That's because we're still compiling the shaders, and there's lots of shaders to compile for a scene like this. And once that's done, this is going to look super gorgeous and pretty. So that's what we're aiming to get, is into being able to have this level here. I'm going to make that my default map. So I'm going to go over to settings, project settings, then to maps and modes, and I'm going to change over the editor startup map to be this one, which I think was called map 1. So just going to search for it. Same for the game default mode, is also going to be map 1 for now until we create our own, and I can go ahead and close that down. The other thing I wanted to show you in the asset pack is the Paragon Wraith, which comes from Epic's cancelled Paragon game. And if we go into the Paragon Wraith characters, heroes folder, Wraith, then we're going to see this guy. If we go and have a look at his blueprint character, which again may take a little second to load, and once that has opened up, you can go to the viewport to have a look at the blueprint.
Hello and welcome to the Dungeon Escape section. In this lecture, I'm going to show you the game that we're going to build, and then we're going to go through the action plan. You can see that the game is set in this awesome looking dungeon, and in here we're going to create a couple of different puzzle mechanics. First of all, we have this pressure plate right here. If I get on top of this, it is going to activate a mover component that is going to move that cell wall out of the way. You can see that inside of there is an item that I can pick up. This is the second type of puzzle that we're going to build. Let's get out of there before the wall comes back up. And we're going to be able to place this item down inside of a lock actor, like this secret wall right here. When I do that, again, a mover component is going to make it move down into the ground, giving us access into the script. In here, we're going to find the final item that we need in order to escape this dungeon, which is this metal statue right here. We can left click on these items to pick them up, and once we do that, it goes into our inventory. We can have multiple items at the same time inside of there, and we're going to be able to place these down, like I just said, into lock actors, and we have another one of those actors right here. I can left click on this and place the item down. I can also left click again and take it back into my inventory, and you can see that that is activating and deactivating that mover component, which is opening up the way into the end of the game, which is basically escaping the dungeon into the light. So that is an overview of the game that we're going to build. There is more to this, but this is just a simple overview. Now let's take a look at the action plan. First of all, we're going to create a new project with the first person template. With the template, we're going to get a bunch of good stuff like the character controller, which is going to be great. After that, we're going to set up a cool test level that we're going to use until we import the assets. And I'm going to show you how to set up this level from scratch. We're going to learn how to create all of the actors that make the scene look great. And in order to do that, we're going to learn about lighting system in Unreal. We're going to learn how to create a skylight. Like how to create an atmosphere, how to create the clouds, and of course we're also going to learn about the spots. Everything is done. We're going to dive into the item a lot with a ton of information. Hello and welcome. In this, set that as the default map or the default level. Let's get started. Okay, so first of all, open up the project and then make sure that you pick the template, all of the assets that were added. For example, there's a folder here called first person. Here is the example map. It's called level_first person. In here we have some blueprints. So for example, the first person character blueprint is right here. And we can also take a look at the Visual Studio project that was generated for us. Let's just get rid of these unnecessary things. Open up Dungeon Escape source, and you can see that here we have a bunch of code files that were generated for us. You don't need to understand any of these right here. I just want you to see them. For example, we have Dungeon Escape character.cpp and .h. These are the code files that create the first person movement that we just saw. And might as well, we can also take a look at the first person character blueprints. You can see that it is just a character mesh with a camera right at the head area to give that first person feel. We are going to customize this character controller to get something that we want, because currently it doesn't really fit the game that we're gonna make, but we will do that in the upcoming lectures. In this one, the only thing I want to do is to create a new level, and then we're going to set that one as the default level or the default map. In order to store the assets that we're going to create, let's go into the content folder, right click here and click on new folder, and I will create a folder called my stuff, and everything I create, I will store it here for easy management. Inside here we can right click and click on level to create a level. That will create a level that is empty, which is what we want. Or we can also go into the file menu, new level, and then pick empty level here and then click on create. I want to create an empty level because I want to show you how to add in all of the actors that make the level look good. So for example, in this example level, if you take a look at the outliner, we have a bunch of actors here inside of this lighting folder. Actors like the directional light, exponential height fog, sky atmosphere, all of these actors combined create the lighting and the visual look of this level, and I want to show you how to achieve that by yourself by adding the actors manually. So that is why we're going to create an empty level, and I'm going to give that as a challenge to you. So go ahead and create a new empty level called test level. I want you to save it into the my stuff folder that we just created, and then I want you to set it as the default map inside of the project setting. So you can just black here. Menu, we're going to use a geometry brush for this. So we'll just bring in a box brush. It's going to look completely black because we don't have any lights in the scene. I am going to reset the location of this to 0, 0, 0, and then I'm going to set its scale. So in the brush settings, we'll say isn't large enough later liner, we don't have any lights, and that is to go into this menu right here and change the view mode to be unlit. Once you do that, you can actually see all of the actors within the game world, and then into the void. Let's also go into the menu here and create a player start. Make sure that the player start isn't in the ground, and then we can play, change the view mode to be unlit, and then we can actually see what's going on. Okay, so that's going to be it for this lecture. In the next one, we'll learn how to create. Hello and welcome. In this lecture, we're going to learn how to do the lighting setup for the empty level we created. Let's go ahead and get started. Okay, so first of all, let's go back into the lit view mode. And once we do that, you can see that then to do that, called a directional light. Let's bring this into, it's infinitely better. We usually just hit the sky so that, and if you actually look, to do that, we need to go into the visual effects menu and we need to bring in a sky atmosphere actor. Once we do that, we can now see this beautiful blue sky, as you can see. And if you actually look up, you can see the sun. If I change the rotation, let's create the bottom half of the sky, because you can see that the bottom half is completely black still. So we need to include another visual effect actor, which is called an exponential height fog. Let's bring this in as well. And now we have the bottom half of the sky, which is looking kind of good. With these actors, location doesn't matter, just like the directional light. So for both of these, we can just starting to get a sky and atmosphere that is looking better, called volumetric cloud. We can also position this at 0, 0, 0, and now we have some nice looking clouds in the game world. Great, we're almost done. The final step is bringing in another light actor called skylight. Let's set this at 0, 0, 0 as well, and this is a lot more subtle light. So for example, if we turn it on and off, you can see that it is slightly impacting the lighting, but it's going to be important, as you'll see in just a second. Now we can play the game and see what it looks like, and we have this nice looking sky that we're used to from the test levels. Awesome. Next up, I'm going to give you a challenge. The challenge is to create a cube using a box brush inside of the game world. Just place it on the ground, and then I want you to play with the Y and Z rotation of the direction. You're done. Again, immediately get this Z rotation with the Z, and we can thing that is like that in mind as you're updating the directional light. So for example, now we can bring it up in the sky, just like that. You should also go into the skylight and recapture it so that it updates it. You can also go up in the skylight details here and click on real-time capture, and that way it's going to update immediately without you having to click on recapture. Great, so that is the challenge. I hope you had fun with that. It's always fun controlling the sun. Next up, about the mobility settings of these lights. So if we click can't and change, going to be huge so that we can manage them more easily. Here I'm going to right click, create a new folder. We'll call this the lighting, and then I'm going to click on the direct is a material color. We can left click hold and drag this onto a surface material, them in here, content. And now we have only the surface to or is just like that. Rotate it a little bit. Add more. Of course, to do the enjoy the design parts. Welcome. The first the F8 key called Dungeon Escape Character. that class that the blueprint as many children as you want and call it the root component. You need to expand it just like I said. I'll have a link. Hello and welcome. In this lecture, we're going to talk about inheritance and composition. Let's go ahead and get started. Okay, so inheritance and composition, these are two ways of designing code, and so far in the course we have been using inheritance quite a bit. Inheritance is when a child class automatically has all the functionality. Hello and welcome back. In this lecture, we're going to learn about the input system and create a new input action. Let's go ahead and get started. Okay, so now that we created the lock and the collectible item, we want to go ahead and implement the interaction system. We want to be able to left click on these and interact with them. But before we can do that, we need to be able to detect when the left mouse button is pressed. In order to do that, we need to use the input system of Unreal. And the first step usually is to set it up, but since we use the first person template, it is already set up for us. That's why we have been able to run around and jump. This is all being done with the input system. In this lecture and in the next one, we're going to take a look at how that setup was done, and we're going to create our own input action for the left mouse button, and we're going to call it the interact input action. Now, the input system in Unreal is a little bit complicated and it takes some time to really master it. In these next couple lectures, we're just going to take a brief look at it more and more. In here, we're going to represent an action that we can on the mouse or on the gamepad. This mapping section, we can unfold this to take a look. This is going on the one we do in the engine to right click that we're going to call IA, which stands for input action underscore interact. Just like that, we can save it by hitting Ctrl S and then go back into the mapping context. Just like these ones right here, we're going to create a mapping for IA interact by clicking on this plus icon, and then from the list we're going to pick IA interact, just like that. We can this is and find the that is going to be true input mapping. Go ahead and click on this, just like plus plus will get called. Welcome back. In this lecture, we're going to learn how the input system is set up within C++ and connect our new input action to a function so that when we press the left mouse button, we get a log message. Let's go ahead and get started. Okay, so in the previous lecture, we learned how the input system was set up within the editor, and now we're going to learn the next step, how this is all being used in C++. Basically, it is going to be a two-step process. First of all, we're going to register the mapping context. That is going to be the first part. And after that, we're going to connect each of our input actions to a C++ function. When an action is triggered, the connected C++ function will get called so that we can do something about it. For example, when the input action jump is triggered, a jump function is going to get called, making the player actually jump. These input actions by themselves don't do anything. We have to connect them to the C++ functions so that they actually execute some code. Okay, so let's go into Visual Studio. First of all, we're going to take a look at how the mapping context is connected or added into the game, and that is going to be done inside of this class, Dungeon Escape player controller. You can find this within the Solution Explorer, and you can open up the header and CPP files. A quick disclaimer, we're going to see a bunch of new concepts that we haven't covered yet, but don't worry, we're just going to take a look at the code. I'm going to explain what each part of the code does, and we're not going to do a very deep dive, so don't worry if you don't understand everything fully. You're not supposed to at this level in the course. We're just going to roughly understand how the system works and then connect our new input action to a function. So first of all, inside of this class, we have a variable that is edit anywhere, and this is called default mapping contexts. This is an array, and that means this can hold multiple values of this class type, which is an input mapping context pointer. This variable is used so that we can create a connection between the assets we created in the editor and this C++ class. We can actually take a look at that. If we go into the first person folder, into blueprints, we have a blueprint class created from the class that we just saw, the player controller, which is right here. If you open that up, in the details at the top, you will see that variable, default mapping contexts. You can unfold it to see what it has. You can see that it is an array and it has multiple values inside of it, and these are the assets that we created, the input mapping contexts. We're setting them here so that we can use them inside of this class. Next up, we're going to take a look at the CPP file. In here we have a special function called setup input component. This is used to do some setup related to the input system. In here, three things are happening. First of all, we're getting a hold of a subsystem, which is the enhanced input local player subsystem. We need this to add the mapping context. And after we get it, we're doing a for loop, basically going over each element in that array. Inside of this loop, we're adding those mapping contexts into the game using that subsystem. So like I said, we haven't covered the for loop yet, and we haven't really covered doing something like this in an if statement. All you need to understand here is that we're taking all of those mapping contexts that we assigned in the editor, and we're adding all of them into the game. That is what's being done. inside of the player controller. Now let's take a look at the input action setup, which is being done inside of Dungeon Escape character. So we're going to open up the CPP and header files. Inside of the header file, if you scroll down, you will see a variable for each one of our input actions, and the type of those variables are uInputActionPointer. This refers to the input action asset, and the type of variable we had within the player controller refers to the mapping context asset. You can see that we have one of these variables for each input action within the game, except for the one we created. We're going to do that ourselves in just a second. And you can also see that these variables are edit anywhere, so that we can set them from the editor. We can see these within the player blueprint, so let's go into the editor. Let's go into our own stuff, BP player. We can go ahead and scroll down until we find those variables. Right here, you can see that jump action, move action, look action, mouse look action, they're all being set to the correct input action item. That is the purpose of these variables, so that we can set them from the editor and create that connection between that C++ class and these input action assets. And the reason these are displayed inside of the input section is this category input argument that is you are creating. I'm going to scroll until we get to the setup player input component function. This is again a special function used to do some input system related setup for the player. Here, first of all, we are getting a hold of the enhanced input component. Using this component, we can call a function called bind action, which is going to take in an input action, and then it's going to connect it to a function that we're going to provide. For example, right here, we're taking the jump action and we're connecting it to the do jump start function, which is somewhere down here, right here. There's one important thing about these connections, and that is this trigger event type. This is going to determine at which point the function gets called. Right now, there are three different options that we need to understand: started, completed, and triggered. Started means that the input action is just started. So if we are using a key, it is just being pressed. If we're using a mouse button, it just got pressed. If you use this type of trigger event, the function is going to get called only once at the start. Next up, we have completed, and this is when the input action is over, when you take your hand off of the key or when you take your finger off of the mouse button. If you use this one, this is also going to make the function get called once when the input action is completed. And finally, we have triggered, which means the key or the mouse button or the gamepad button is currently being pressed down. It is being triggered. If you use this type of trigger event, the function that you connect will get called continuously until you stop triggering the input action. And you can see that the move action is connected using the triggered trigger event. For something that needs to happen once, like jumping, we can use the started action, but for something that needs to happen all the time, like moving, we need to use the triggered events. So moving, for example, as long as we have the keys held down, we want to continue moving, but for jumping, when we press the spacebar, for example, we only want to jump once. So that is how the connection between the input action and a function is created. You can see that we're passing the address of these functions using the full class name, scope resolution operator, name of the function, and of course the ampersand operator to get the address. We're also using the this keyword right here, but like I said, we're not going to get into too many details just now. So
the blueprint and have a look at the Wraith character. Now, again, compiling shaders. Quite a lot of heavy assets in there. Make sure you can go and have a look at it. There's a few different asset packs that I've aggregated together. I have created all of these folders under, and to the content that pack folder where empty content, a lot of hiding that some files were not closed down, the shoot downloads if you like, or keep the modular to make it simple. And what we're going to have a look at is the collection maps, and map number 1. Go ahead and load that one up. So once that has opened, and it can take a while depending on your machine. For me it took about 5 or 10 minutes to open this map, but don't worry, once you've opened it once, it's going to be a lot quicker in future. And what you're going to see is this kind of environment. At the first, it might be not particularly pretty, as you can see over here. That's because we're still compiling the shaders, and there's lots of shaders to compile for a scene like this. And once that's done, this is going to look super gorgeous and pretty. So that's what we're aiming to get, is into being able to have this level here. I'm going to make that my default map. So I'm going to go over to settings, project settings, then to maps and modes, map 1, close that. On epics, cancel. If we go and have a look at his blueprint character. Again, may take a little second to load. And once that has opened up, you can go to the viewport to have a look at the blueprint and have a look at the Wraith character. Now, again, compiling shaders, so you can't see the shaders on this guy. He is very pretty once you can. So do go ahead and open all these assets up. It will start the shader compilation process, and you'll be able to see what we're going to be working with. So that's it for me in this the blueprint, and have a look at the Wraith character. Now, again, complete the shader compilation process, and you'll be able to see Hello and welcome. In this lecture, we're going to be learning about the difference between pawns, such as this guy, and characters, such as this guy. And we're going to go ahead and set up a character blueprint and character C++ actor to look like this, so that we've got our Wraith mesh. Let's dive in and see how it's done. Okay, so the first part of our greater project plan that we're going to want to start on is the player movement. That's number 1. That's what we basically fundamental of most games, not just shooter games. Then they would be going on to animation and shooting and health and enemy death and all those other things that we want to get to. But the first thing to tackle is the player movement. To do this, we're going to create a character class. Now, what's a character class? Well, first and foremost, there's a distinction between a pawn and a character. The pawn is anything that you can possess as a player. We'll talk more about possession later, but you'll have seen a little bit about it before already. But the idea, what's a character? It adds floor movement, which we'll see more when we get to the A. Amongst the options, there is pawn and there is character. Create a character. Very much the same as we would create any other C++ class. We go to add new C++ class, and you can see here amongst the options there is pawn and there is character. Now I'm going to go ahead and give you a challenge right off the bat to create the blueprint children and the C++ for that matter. So we're going to first of all follow along to create the C++. This is not going to be part of your challenge. We're going to create ourselves a pawn, which I'm just going to call my pawn because we're not going to be using the pawn, but we're going to want to see the difference between that and the character. So we go ahead and create that class. And once that goes ahead and finishes, you'll end up with a pawn class, the sort of thing that you will have seen before. It's got a begin play, a tick, setup player, input component, etc. So what we're going to do is we're going to do the same procedure again, add new C++ class. This time we're going to create a character, go to next, and instead of calling it something unimaginative like my character, I'm going to call it the shooter character, which is more descriptive about what kind of character we're trying to create here. And we're going to go ahead and create that class. And when that's finished building, you can see that we get a pretty similar looking header file. In fact, pretty much everything is identical except for what it inherits from, the character class instead of the pawn. It's very, very similar other than that. So to see the differences, we're going to have to look at the blueprint children of these things to see what kind of components are there. So that's going to be your challenge, to follow along to create the C++ as I just did. Add a blueprint child for each of those, the my pawn and the shooter character. Then what differences can you see when you open up those two separate blueprints? Pause the video and have a go. Okay, welcome back. So let's give this a shot. If we go into the editor, and I'm just going to navigate to the top of my content directory, and then I'm going to add some new blueprints. So I'm going to right click, create a blueprint class, and instead of inheriting from one of these, I'm going to select all classes and look for the my pawn class, which is a child of the pawn, as we can see. Select that one and go and create an override of that. I'm going to call it the BP underscore my pawn to use that convention, which helps us differentiate between the C++ and the blueprint. So I'm going to then right click and create another blueprint class. This time I'm going to be looking for the shooter character and select that one, and predictably I'm going to call it editor, and I'm just going to navigate to the top of my content directory, and then I'm going to add some new blueprints. So I'm going to right click, create a blueprint class, and instead of inheriting from one of these, I'm going to select all classes and look for the my pawn class, which is a child of the pawn, as we can see. Select that one and go and create an override of that. I'm going to and the blueprint. So I'm going to then right click and create another blueprint class. This time I'm going to be looking for the shooter character and select that one, and predictably I'm going to call that BP underscore shooter character. It kind of helps us in terms of not having to be too imaginative about naming things. You don't want to be imaginative about naming those blueprint children. You just want to be able to say it's going to be exactly the same name, just with BP underscore on the front. So let's go ahead and open those two up and dock them to the main window so we can compare them nice and easily. Open up the shooter character, docked to the main window, and straight away we can see some differences. The pawn basically has nothing going on in the component view. It has a default scene root and nothing else. If we go over to the shooter character, however, you can see that there's a few more things going on. For a start, we have got ourselves a capsule component here, which is kind of implying already that it's expecting a humanoid shape to fit inside that capsule. The capsule is for doing rough physics and manipulation or collision with the terrain, and then obviously something that fits inside that very nicely is a humanoid character. We've got an arrow component which just basically tells us which way is forward for this character. And then we have a mesh, which is it's inherited from the C++. In fact, it's inherited from 2 levels up, because we haven't defined any meshes here in the A shooter character. They must have been defined up in the A character class instead. So that mesh component is trickling all the way down here to this blueprint class, and it doesn't have anything in that mesh just yet. So we can go ahead and put a mesh in there. So let's go ahead and try that. Go over to the details pane, to the skeletal mesh, and we want to basically put in our Wraith character. So I'm just going to select Wraith in here, and there we go. It has put him in a little bit off the ground. So what I want to do is go ahead and adjust his feet so they meet up with the bottom of the capsule as best I can manage. Looks like I pretty much got that right first time. And then we want to also align him so that he is facing towards that forward arrow, so we can do a little bit of rotation magic. 90 degrees that way, and we are golden. I was hitting the R key to get to the rotation widget, by the way, or you could use these little widgets at the top right of your viewport to get between your translation and rotation. Another thing that's worth noting here for each of those, the my pawn and the shooter character class, instead of descriptive about what kind of character we're trying to. A pawn class, the sort of thing that you will have seen before. It's got a begin play, a tick, setup player, input component, etc. So what we're going to do is we're going to do the same procedure again, add new C++ class. This time we're going to create a character, go to next, and instead of calling it something unimaginative like my character, I'm going to call it the shooter character, which is more descriptive about what kind of character we're trying to create here. And we're going to go ahead and create that class. And when that's finished building, you can see that we get a pretty similar looking header file. In fact, pretty much everything is identical except for what it inherits from, the character class instead of the pawn. It's very, very similar other than that. So to see the differences, we're going to have to look at the blueprint children of these things to see what kind of components are there. So that's going to be your challenge, to follow along to create the C++ as I just did. Add a blueprint child for each of those, the my pawn and the shooter character. Then what differences can you see when you open up those two separate blueprints? Pause the video and have a go. Okay, welcome back. So let's give this a shot. If we go into the editor, and I'm just going to navigate to the top of my content directory, and then I'm going to add some new blueprints. So I'm going to right click, create a blueprint class, and instead of inheriting from one of these, I'm going to select all classes and look for the my pawn class, which is a child of the pawn, as we can see. Select that one and go and create an override of that. I'm going to call it the BP_my pawn to use that convention, which helps us differentiate between C++ and the blueprint. So I'm going to then right click and create another blueprint class. This time I'm going to be looking for the shooter character and select that one, and predictably I'm going to call that BP_shooter character. It kind of helps us in terms of not having to be too imaginative about naming things. You don't want to be imaginative about naming those blueprint children. You just want to be able to say it's going to be exactly the same name, just with BP_ on the front. So let's go ahead and open those two up and dock them to the main window so we can compare them nice and easily. Open up the shooter character, docked to the main window, and straight away we can see some differences. The pawn basically has nothing going on in the component view. It has a default scene root and nothing else. If we go over to the shooter character, however, you can see that there's a few more things going on. For a start, we have got ourselves a caps inside in that mesh, so they meet up with the bottom of the capsule as best I can manage. Looks like I pretty much got that right first time. And then we want to also align him so that he is facing towards that forward arrow, so we can do a little bit of rotation magic. 90 degrees that way, and we are golden. I was hitting the R key to get to the rotation widget, by the way, or you could use these little widgets at the top right of your viewport to get between your translation and rotation. Another thing that's worth noting here in the component hierarchy, apart from the fact it's got this mesh, the arrow, and the capsule component, is we've got this character movement component. This is what is entirely responsible for giving it character-like movement, being able to walk and run, etc. You can see here in the details pane we've got a bunch of movement settings. We've got the gravity scale, so you could make it look like we're playing on Mars or on the moon or on Jupiter, whatever you want to do. You can change the gravity scale, it can be fun. We've got default movement types for whether we are on land, whether we are on water, all this kind of stuff. Walking, jumping information, network stuff. This automatically works well in multiplayer games. It's got all that built in. So basically lots of stuff already being done for us here. So that's why we want to use a character over a pawn, where we would have to write all of this movement code from scratch. If we use the character, it's already set up with this character movement component for us. And that's far from being all of the things that the character provides for us. It also provides lots of niceties and nice functions that we can call in the base class to get our job done even more easily. We'll be seeing that in upcoming lectures. So the final thing we might want to do is make sure that this character is the pawn that gets spawned in our map. So the way I'm going to do this is going to the root of our content again, and this is revision, so mini challenge for you if you want it, where you could go ahead and create a clone of this map and a blueprint game mode set from this map that will spawn our BP shooter character. Okay, I do encourage you to attempt these mini challenges as well as the main big challenge. I'm going to move on though and reorganize things a little bit later as the route gets a little bit more stuff in it and the organization structure becomes clearer. I'm going to rename that map to Sandbox. I'm going to set it as the project default by going to project settings, maps and modes, and then changing it from map 1 to Sandbox for both the game and the editor. Then I'm going to make a game mode. So I'm going to right click and create a blueprint class. I'm going to create a game mode base blueprint, call it BP_shooter game mode. I'm going to open up that. I don't need any C++ in this base class, so I'm basically not deriving it from C++, but once we do need it, we can always reparent blueprints to C++ classes of our own devising. So what I'm going to do is go over to the details. If that's not selected for you, you need to go to class defaults here in the top bar, and then you can go to classes section and find the, it should be something like the default pawn class, like so, and we're going to look for the BP shooter character. We want the blueprint version because it's got the mesh set up. And then we're going to go back to our sandbox, open up our sandbox, and change out its game mode. Now, the reason I've created a sandbox is because I don't want to be editing the original map, because I might always want to go back to that one for reference if I've mucked up my sandbox. So let's go to the blueprints drop down in the top bar and select the game mode. It's currently set to game mode base. I'm going to select instead the BP underscore shooter game mode, and the final piece of the puzzle is going to be to put in a player start somewhere. In actual fact, I didn't realize this, but the map already contains a player start, so adding this extra one means that you can now accidentally spawn in 2 separate places. We'll fix this later on in the course, but just so you know, if you end up spawning in a different location and you're getting confused, that's why. So go to your Place Actors tab over to the left. If you haven't got it, go to Window and select Place Actors to make it show up. And we want Basic Actors, we want the Player Start Act. If you just go ahead and bring that in, it gives us this little capsule with a forward arrow. Is whether that's it. If you turn around, you can see that sure enough, place, and we are going to be continuing from this to fix up the animations, get a third-person character, and so on, and get it moving, most important. Hello and welcome. In this lecture we're going to be looking at hooking up our character movement so that we can move forward, strafe, and look around our world. The classics of moving around in a first-person or third-person shooter. Let's dive in and see how it's done. So continuing along in the vein of trying to get our character movement working, we are first of all going to want to bind some input, but we're also going to want to know what to bind that input to. Fortunately, when it comes to characters, there's a lot of simplifying stuff going on for us. After all, Unreal really is an engine that's optimized for making things like shooter games, character games. And let's have a look at some of the movement functions that are already provided for us by the character actor class. Not just the character movement component, but also the character actor class provides these, and it often passes a lot of this on to the character movement component, but not necessarily. So let's see what movement functions we're going to be dealing with. First of all, there's going to be add movement input. Add movement input basically takes a vector and tells you which direction you're going to move in. So if it's a forward vector, you move forward. If it's a backwards vector, you move backwards. If it's a right vector, you move right, and so on. And the size of the vector is going to determine how fast you move in that direction. The next thing is we've got add controller pitch input. So that's about looking up and down, which is obviously very useful when you've got your mouse. You want to be looking up and down by moving your mouse up and down. Then there's add controller yaw input, which is going left and right. And finally there is a jump function, which is just that. Maybe you hit the spacebar and you jump. So with these things in mind, what we want to go ahead and do is create some bindings in character actor class that bind some input, or some inputs from your keyboard, your mouse, your controller, to these functions. So we're going to do a few, and then we're going to do a challenge to do the rest. So let's go over to Visual Studio Code, and I'm in my shooter character.h, and we notice that we've got already here the setup player input component function. This is where we need to bind our input. I'm going to hit F12 to go over to the C++. I'm going to hit Alt-O to go over to the C++ and find where we've got that set up. So the first thing is it gives us this player input component that we want to bind with. If you remember, this is the way we do it. We have a player input component, use the arrow operator, and we then do a bind function here. So it's either a bind axis or it's going to be a bind action, depending on On whether it's a discrete action such as jump, or whether it is an action that's going to be a step even things and mappings up. But if I want, so because this is the move forward method, we want to have
So for the jump action, the do jump start function will be called when the input action starts. So let's take a look at that function. To do that at the bottom, we will create a void, interact, it just got pressed. BP player is variable is being passed into your property. That is the reason. You can create. We're going to scroll down a little bit in order to bind to those input actions. So let's go into the CPP file and see how that connection is being done. We're going to scroll down a little bit and we're going to scroll until we get to the setup player input component function. This is again a special function used to do some input system related setup for the player. Here, first of all, we are getting a hold of the enhanced input components.
just yet. So now what we've done is we've created a link to let's take a look at the event graph, and on begin play, but when the
tercer espacio, es decir, la 02, la segunda L del cuarto espacio, que es decir, la partícula lo que os he pasado. Ningún tipo de problema más. Successfully linked patch, lo que tenemos aquí. Piso de accesibilidad, público, protegido y público. Y debajo, vamos a crear la definición. Modelo, es la capacidad que nos queda de aquí abajo para poder acceder a toda Unreal, porque tengo que buildear uno de los cambios gordos que entre el editor y el IDE hay que hacer más cosas. Es decir, ahora mismo se han quedado ciertos cambios guardados en la caché de Unreal y no está reconociéndome ese input, ¿vale? Este include, ese archivo. Voy a volver aquí a comentar. Fijaros cómo ya me lo está cogiendo sin ningún tipo de problema. Con eso lo que hemos hecho directamente es acceder. Entonces nosotros lo que vamos a utilizar, podríamos añadir el encabezado del input mapping context aquí arriba, pero añadir un de enhanced input component argumento. Me dice funciones, si quiero exponer funciones en el editor, hay otra macro que es uFunction, ¿vale? Y luego todo esto pues tiene especificadores, los especificadores que nos ayudan a terminar de marcar estos son. Quiero que sea despliego posibilidad de estamos hablando ahora de esto va a ser llamar para el input el vector de dirección que se llama en este caso, se va a llamar forward. Ahora lo ahora D, ¿vale? ¿Qué es el vector 2D? Esto, el eje, el axis y el
as a fast build it in with it. So X not adding the code hand so you can run around.
Unreal Engine now has enhanced imagery. Go straight to Visual Studio and go under Game. A whole bunch of stuff required for in content and what. And we have an input player character. As per usual, we need to fit. So first of all, we need to link up the thing context, artworks.
Using this component, we can call a function. Right here, we're taking the jump action and we're connecting it to the ultimate, at which point the function gets, and the function is action that the move is not gonna get, and after that, we're going to connect it.
To have the forward vector of the actor. So the way we do that is we can do a get actor input, like so. So because this is the move forward method, we want to have the forward vector of the actor. So the way we do that is we can do a get actor forward vector, like so, and then we want it to be forward in the amount that our axis value gives us, so we can multiply by the axis value, and that's going to give us the right result. So we're going to have the forward vector multiplied by the axis value. If it's 1, we go forward. If it's -1, a forward vector becomes a backwards vector, and we go. Going backwards with just this one function. So that's set us up with our move forward. Great. The next thing is to bind for our look up. So let's go and copy. I always like to copy these string references so that I don't make a mistake. Do a look.
primary control of critical vehicle function.
Look up, and instead of binding to move forward P and do create implementation, goes ahead and saves me a little bit of time. And this time, instead of doing add movement inputs, we want to use one of those other functions that we had at our disposal. Pitch input and pass in directly the axis value. Now the a bit more experienced C++ programmers among you could call the function directly, couldn't we? Space, something like that. And here we've got a pawn, add controller pitch input, so that it automatically just directly calls that parent function rather than having to go via our own function. This is a valid way to do it as well, but it's just not necessary. So I'm going to comment it out so that you can refer to it and see it if you wanted to do it that way. I would recommend doing it the slightly shorter route, like so. Doing that with a Control-Shift-V, we need to use errors, one being that I've got a function call, and the other being that I hadn't got an ampersand in front of the function, so go over into Unreal and see those two very common errors, one being that I got the wrong function call, and the other being that I hadn't got an ampersand in front of